So another topic is about the Newton's law of cooling. So we have the equation here, which is dt over dt, then equal to negative k times a t minus ts, where t is equal to temperature of the body at any time t, and ts is the temperature of the surroundings, and it is also called the ambient temperature, and t0 is equal to the initial temperature of the body. And we have the problem here, a thermometer which has been at the reading of 70 degrees Fahrenheit inside a house is placed outside where the air temperature is 10 degree Fahrenheit. So 3 minutes after, or 3 minutes later, it is found that the thermometer reading is 25 degree Fahrenheit. Find the thermometer reading after 6 minutes. Okay, for the first step, we need to find what is the TS, and our TS here is the temperature of the surroundings, where we can find that is the negative, I mean the 10 degrees Fahrenheit. So this is our TS, and equal to negative 10 degrees Fahrenheit. So from our equation, that is dt over dt, then minus k t minus ts, whereas our ts is 10. And we just need to rewrite our equation into uh, by using separation by variables. So we have dt over t minus 10, and we also have negative k dt. And from this equation, we can simply integrate both sides. And for the left hand equation, that is our dt over t minus 10, if we integrate this one, we will come up with ln t minus 10. And for the right side or right hand equation, whereas our k there is our constant, so we have negative k t, then plus ln c. I will just use ln c, guys, because it is faster than rather than using c alone. Okay, so for this one, we can also rewrite our equation negative kt as ln, then e raised to negative kt plus ln c, so that all the equations are used with natural logarithm. And after this one, we need to combine both equations from our right hand equation. Okay, and this is ln c, then e raised to negative kt. Okay, and from this equation, you can simply cancel both ln on both sides. And from this equation, we have t minus 10 is equal to c, then e raised to negative k t. Or we can simply write this one as t is equal to 10 plus c e raised to negative k t. And after this one, from our time is equal to 0, we have a temperature reading as T is equal to 70 degrees Fahrenheit. Okay, and from our equation here, you can say that we have 70 then equal to 10 plus the constant and e raised to negative k times the time 0. And we know that e raised to 0 is 1. So we have c. Hence our constant here is 70 minus 10 or 60. Hence our new equation will be t is equal to 10 plus 60 e raised to negative k t. And again, we need to read, or we need to use the 3 minutes time at time 3, and we have the temperature 25 degrees Fahrenheit. And again, we need to substitute this equation from our new equation. Let's say this is our equation 1 and this is our equation 2. Okay, from here we have 25 is equal to 10 plus 60, then e raised to negative k times 3. So we can rewrite our equation as 25 minus 10 then equal to 60 e raised to negative 3k. Then we have 15 is equal to, okay, we just need to transpose 60 to our left hand equation, that is 15 divide 60. Then we have e raised to negative 3k. Okay, thus our e raised to negative k is equivalent to 15 over 60. This is raised to 1/3. Okay, we just cube both sides. Need to get the cube root of both sides. Okay, so from here we need to simplify our equation. So we have 15, 60 divided by 15 is 4. So we have 1 over 4 raised to 1/3. Okay, thus our equation, t, right, our new equation t is equivalent to 10 plus 60 times 1 over 4, which is equivalent of our e raised to negative k, that is 1/3 multiplied by t. So our equation again is 60 times 1 over 4 t over 3. Thus after, this is our third equation. Thus after, at our time is equal to 6 minutes, we have t is equal to 10 plus 60 times 1 over 4. Then we have 6 over 3. Then temperature is equal to 10 plus 60, and that is 1 over 4 times our raised to 2. And we have t is equal to 13.75 degree Fahrenheit if we calculate the last equation. Thank you.